Hello, I'm Ward Bell of IdeaBlade with another in a series of videos about the TempHire cocktail reference application. My good friend and colleague Marcel Good is the chief architect and principal maintainer of Cocktail, an open source framework for end-to-end development of XAML-based business applications. Marcel gave me a guided tour of the TempHire application, and this series is the result. This TempHire project video closes out the topic with a survey of a few of the components that support the TempHire client UI. We'll see how to identify the user and his permissions with the authentication service, create and share entity managers with the EntityManager Provider and its factory, configure the Entity Manager events and validation with the EntityManager Delegate, synchronize entities across multiple Entity Manager caches with the synch interceptor, and cache reference data with the global cache. Here's Marcel to tell us about it.
The main application also handles the login and the logout through the Cocktail authentication service.
We actually saw it expressed in the shell view model, but this is Cocktail.
This is Cocktail. It encapsulates the act of login and logout.
Right.
So we simply use that, and the reason it's subclassed is we're publishing messages when we're logging in and logging out, because the UI might be interested in knowing that you're now logged in or you're now logged out.
Yes, mine tends to be.
Yes. So we simply publish that to the event aggregator if somebody's interested or not.
Whose event aggregator is that?
This is the Calibre Micro event aggregator.
Mm-hmm.
It's nicely encapsulated in this event function static class, so you don't actually need to inject the event aggregator.
Right. Usually we inject things, but some things that are just used everywhere and are instantly recognizable, we say, let's put those in statics. Let's give static classes to give access to them.
Exactly. And then the last thing on here is there is a differentiation between authentication and needing the active user, right? Only the shell and the login view model really need to interact with the authentication service. They do the login and they do the logout. The rest of the application only needs the current user.
You mean if I'm editing the address type, I don't really need to log the user in and out?
Generally, you don't.
No, but I might need to know who that user is in order to have business logic.
Yeah. So for that reason, there is a user service that is laid over the authentication service that simply gives you the active user back.
Right. So again, if I'm in the address editor, I needed to know something about the user to do it. I'm thinking in terms of the iUser service interface, which only tells me who the user is, and I have no idea that its implementation does other stuff.
Exactly.
Got it.
Yeah. So this is the authentication service. Then we have three more things to talk about. We have the EntityManager Provider factory, which is responsible for spinning up new EntityManager providers when we need them. Like, remember, the unit of work needs an EntityManager provider. Everything that interacts with data somewhere needs an EntityManager provider so it can get an Entity Manager to work with. So we have a factory class here that creates new Entity Manager providers on demand, and it configures them if necessary. We can see if we're running in a fake store, we configure it with the fake connection options so that the Entity Manager will actually connect to the fake store rather than the database. So that's all there is to the factory. And the second piece is the Entity Manager Delegate. Again, a cocktail concept. It allows you to react to certain events that an Entity Manager fires, right? When you save, when an entity changes, when you run a query, things like that. You can centrally react to these events and act upon them.
If I understand, this delegate would be used to configure an Entity Manager before it was handed to, say, a view model, so that all this stuff, all of this on change, on save, and so forth would be wired into the Entity Manager by the time I received it, and I'm just interacting with the Entity Manager.
That's one of the responsibilities of the Entity Manager Provider, to discover the delegates and hook them into the Entity Manager, so that when the event fires, the corresponding method over here is called.
Got it.
Most of the things in here are very simple. We actually just publish events out to the event aggregator to let the UI know that an entity changed, and the UI decides if it's interested in that or not.
Now, why might I want to do that? For example, if I'm in there maybe editing Steven and I change his name to Steve.
For example, the toolbar needs to know that it needs to refresh its toolbar buttons, right? If the entity changed, you want to enable the save button. For example,
okay,
right?
okay.
So that's a good use for this, so that the view model can basically do a notify property change on the can save.
Right. So in the process of editing Steve, if I'm the view model associated with that, I'm just through this mechanism, I'm publishing the fact that I changed it. I don't know if anybody else cares.
Yeah.
Turns out the toolbar cares.
Yes.
But that's the separation of responsibility
Yes.
here. I just say my responsibility is tell the world if I made the change and
Yep.
hope they know about it.
That's correct.
And even the view model doesn't know this is going on because you've wired this behavior right into the entity manager itself.
Yes.
So even I as a view model, I don't have to think about that because
Yeah.
you're going to do it for me.
Yeah, exactly. Yeah. Similarly, when we save, we do the same thing. If the save was actually successful, we publish that. For similar reasons, the view model may need to know that we now successfully saved, right? And again, help the toolbar along to disable or enable buttons.
And I see you're telling me all about all the entities that I happen to save. So
Yes.
if I saved 5 entities, anybody who's listening can know
Yep.
which ones.
Yep.
Got it.
That's correct. And then the validate method is not actually an event that gets triggered from the entity manager, but it's something that gets triggered by Cocktail in the saving event. Cocktail automatically does client-side validation before it lets the save go through. And so the validation can happen in various places. There is the DevForce verifiers that you can have on your entities. There is this custom validation that we see here where actually the entity manager delegate is being told, hey, we're validating an entity here. Do you want to do some additional validation to this entity, right? And all we're doing, you remember from the entity base, there was a
Right.
validate method.
It was virtual and it did
validate.
nothing, but it was
Exactly.
there so you could call it like this.
Yeah. So we simply call that virtual validate method, and any entity that actually has some logic in there can do validation and can add validation errors to that collection that's being passed in.
Got it.
And then the last one is the saving, that's a bit more complicated compared to the other ones. So in this particular case, we're doing a few things that we want to have happen very central every time we save. The first part is we're adding the root aggregate of an entity graph to the save list. So let's talk about this a little bit.
Oh, I know this problem. This is kind of like if you have orders and order details.
Exactly.
And if I change any of the subordinate entities, I have to mark the root as changed.
Yeah.
Okay. That's a whole topic that we discussed elsewhere, isn't
yes,
it?
Yes.
But I get the idea. You're
That
just
is what it does. Yeah. If you have an order details that needs to be saved, it saves the order along with it. Right?
all right. That makes sure that a whole object graph stays in sync.
Yeah.
From a
Yeah.
transaction perspective
Right.
and from a concurrency perspective.
Primarily from a concurrency perspective,
Right.
actually. Concurrency and validation, because you may need to do validation at the order level if an order line item has
Of
changed.
course,
right?
of course. Right. Maybe
Yeah.
I'm exceeded my order limit or something
Yeah,
like that.
exactly. And then the bottom two for eaches, they maintain audit columns, so the entities can actually have audit columns if they extend from audit entity base. And so we can handle this very centrally to set the created and the modified date and the created and the modified user, right? That's the only place we have to think about this. So now every time we save, it maintains these audit columns that are hanging off the entities that extend from audit entity base. Okay, so this is all we want to cover on the delegate. Then Just quickly, the sync interceptor, again, a feature that Cocktail provides. We've mentioned this with the unit of work, right? We have Steve that we might be editing, we have Paul that we might be editing, and maybe there's a list that shows Steve and Paul. Right? So when we save Steve, we want to make sure that any entity manager that also holds a copy of Steve is being informed that Steve has changed.
It's a way for that one to get a fresh copy, but it doesn't have to go to the database to get the fresh copy.
Yeah,
it can
just
just get it
imports
local.
it.
And that would be a lot faster than going back to the database to get it, to get Steve.
Yes. Yeah. And so the sync interceptor simply lets you control which entities you actually want to export and which ones you want to import on the other side. And we simply, in our case, we just import the entities that we have a copy of or where we have the root of it, right? For example, you added a new order line item and we happen to have that order in the cache. We want to make sure we add that order line item to our cache as well.
That makes sense.
The last one is the global cache. The global cache is where we're loading some of the static data that really doesn't change throughout the life cycle of the application. And we keep them here in the global cache so that we can populate any entity manager that we start up, pre-populate its cache with the static data from the global cache.
This might be stuff like colors and shapes and status codes that don't change during the session. And we don't want to keep making trips back to the server every time we bring up a new entity manager to get them, right?
That's correct, yeah. We can save us some expensive round trips for data that once it's cached, there's no need to go back to the server. So we're calling this global cache right after the login. It calls the load async method that, as you notice, starts a parallel coroutine, which is down here. It runs a bunch of queries that are completely independent of each other, so that's why we can do them in parallel.
Right, simultaneously, phone numbers, addresses, rate types, states, they don't have anything to do with each other, just get them, and when we're all here,
yeah, that's correct. We want to load this cache as fast as possible, and the fastest way possible is in parallel. And then once the data is here in the global cache, then the repositories automatically pre-populate the entity managers with this static data, so they don't need to go back to the server.
Makes a lot of sense.
Okay, and that's all we want to cover in the TempHire main project.
That's the last of the TempHire project videos within this series. In the next TempHire video, Marcel and I move on to the common project, a grab bag of utility components that are helpful in TempHire and potentially useful in your own Cocktail application. You'll find this common project video and much more at cocktail.ideablade.com.